Why does math feel so impossible for so many of us? It often seems like this totally abstract world of symbols that has nothing to do with real life. But what if the problem isn't the math itself, but just how we're looking at it? Today, we're going to dive into a really powerful idea that might just change the way you see it all.
Okay, so let's start with a metaphor. I want you to think of mathematics as bread, right? It's fundamental, it's nourishing, it is the absolute foundation that pretty much all of our modern science and technology is built on. You just can't do without it.
But have you ever tried to eat a loaf of plain dry bread? It can be tough, kind of chalky, and just a real chore to get down. Something's definitely missing, right? Something to make it not just edible, but actually good.
And that's exactly the issue. For so many people, doing math feels like trying to choke down that dry bread. The argument we're exploring today is that it's missing the butter. That one simple thing that makes it all go down smoothly. That makes it possible to actually digest and understand.
So what is this problem really? It's got nothing to do with being a math person or not. No, the issue is way deeper than that. It goes right down to the way our brains are actually wired.
I mean, we've all had that moment, right? Staring at a page full of equations and just feeling completely lost. Your brain just fogs over. So why does that happen? Is it just that hard? Well, the idea here is that there's a much simpler, much more basic reason.
And this just lays it all out perfectly. Our brains didn't evolve to shuffle around pure symbols and abstract formulas. That's not what they were built for. They evolved to navigate the physical world, to understand shapes, to pick up objects, to track things that move. That's our native language. Math, the way it's usually taught, might as well be a foreign one.
Okay, so if the problem is that math is too abstract for our very concrete brains, then the solution seems kind of obvious, right? We have to make it tangible. We've got to find that butter for the bread.
And that butter, it has a name, a model. Now, when I say model, I'm not talking about a little toy car. In this context, a model is any physical thing, or even a visual one, that actually embodies a mathematical idea. It's the bridge that connects the abstract world to the real one.
And just to be super clear, we're not talking about some flat drawing in a textbook. We are talking about stuff you can actually interact with. A piece of paper you can fold into a shape, a solid object you can hold in your hand, a little mechanism with parts that move. It's all about giving math a body.
So let's look at a few examples, because this is where it gets really, really cool. You can see how this idea completely transforms these abstract symbols into something you can almost reach out and touch.
Ah, yes, the classic equation for a circle. If you're a student seeing this for the first time, it's just a jumble of letters and numbers and little symbols. It doesn't mean anything to your senses.
Exactly. It's just cold and abstract. It only exists in that world of symbols, a place our brains have to really work hard to even get to. There's no real-world hook for it. And then this happens. The second you draw a circle, the visual model, it all just clicks into place. Those symbols aren't a random code anymore. They're the recipe for a shape you've known your entire life. The abstract suddenly becomes incredibly concrete. All right, here's another one. We all had to memorize this in school, right? The formula for the volume of a box. It's a simple rule, easy enough to just drill into your head. But it's still just a rule, until you hold a cube in your hand. The moment you can feel its length, its width, and its height, or even better, stack little blocks together to build it, that formula stops being a fact you memorized and becomes a physical truth you can actually experience. Okay, one more. Let's take the equation for a parabola. Again, for a lot of us, this is just another abstract function you have to plot out on a piece of graph paper. But watch what happens when you take a simple model, like a hanging chain. The curve that it naturally forms, that's what's called a catenary, and it looks almost exactly like a parabola. It's like gravity itself is physically drawing the equation for you right there in the air. Math becomes a force of nature. So you see, the big point here is that these models, they aren't just cute little classroom tricks. They are the fundamental connection. They are the bridge between the symbolic world of math and the physical world our brains were actually built to live in and understand. This right here, this is the absolute heart of it all. The language of mathematics might be symbols, but the language of human understanding is reality. And models are the translator. They let us see and feel and touch the ideas that symbols can only ever describe. And what's so cool is that this works across the board in math. The simple act of folding paper can unlock deep truths about geometry. A spinning wheel is the perfect model for trigonometry. A bunch of moving rods can make algebra visible. Even a simple shadow is a physical demonstration of mathematical projection.
And when you do this, you see the whole game changes. The goal isn't to memorize a bunch of rules anymore. The goal is to actually see the relationships. Math stops being a list of instructions and becomes a world of beautiful shapes and patterns and structures that you can actually explore.
And that really says everything, doesn't it? The next time you're stuck on some math concept, don't just stare at the page. Ask yourself, what does this actually look like? How could I build this? How could I touch it? Because once you make it real, you finally make it understandable.